Welcome to part 12 of this Python course, which deals with how we can visualize data using graphical plotting. Plotting, which is basically the idea around plotting, is to be able to visualize data. And to do this, we are going to be using a few modules, matplotlib, and we are going to be using a subset of that called pyplot. So we're going to use some of the functions that are contained in the pyplot module inside matplotlib. We are also going to use something called the Numpy module, and I'm going to do one example which uses something called the SciPy module. Now, what you need to realize is that just like any other module, before we can use these modules, we need to import them into our Python program. And to do that, there are the standard commands we use. So for example, we can type import matplotlib.pyplot. And when I do this, I don't like typing matplotlib.pyplot on every single line of code in my program. So I rename it and I call it PLT. And we can also import numpy as, again, I'll rename it to NP. All right, so importing these modules are important. It is the first step that you need to do to be able to use the functions that are contained inside those modules. Now that we've imported them, I can put together a little program to create our first simple plot. Bear in mind, I have not dealt with SciPy yet. We'll import that later when we need it. So let's start off by having a look at a simple line plot. We are going to have two vectors, an X and a Y data vector, and we are going to be able to plot those. So let's start by putting this code together. So the first thing I'm going to do is to import matplotlib.pyplot as PLT. I don't really, strictly speaking, I don't need to do this because I did do it up there, but I'm just doing it for completeness sake so that you can see the whole program code. Next, I'm going to create a list. This is going to be my vector, which I'm going to call X. And I'm simply going to create 5 data points in it, 1, 2, 3, 4, and 5. And then I'm going to create another vector called Y, which I will just generate some random data. So there I have two vectors, X and Y. Both those vectors, as you can see, have exactly the same size. That means they've got the same number of elements in them. This is necessary because when you plot data, those two vectors are plotted against each other, and therefore they need to have the same number of elements contained within them. Now, to be able to produce the plot, the simplest way to do that is to type plt.plot, and then inside parentheses we specify the data that we want to use, and in this case it's the X data and the data contained in the list called Y. And then we can also specify a label for the plot. This is just naming the plot, and your label is a simple string and it can be anything you like. Now, if you are using Spider or one of these online systems like I'm doing, then you do not need the next line of code. But if you are using the standard Python IDE, you are then going to have to type plt.show. And plt.show basically tells Python to visualize that plot on your screen. So if I run that simple 3 lines of code, we end up with a simple plot. So here you can see the first data point, which is at position 1 for X, is 2 position Y. It then jumps up to the second data point at a value of 4 for Y, then down to 1, up to 3, back down to 2. So we end up with a simple data plot displayed on your screen. The next example, I'm going to be using exactly the same program, but this time I'm going to show you some of the extra parameters that you can give to the plot function. So what I'm going to do for the next example, I'm just going to copy exactly the same program and I'm going to paste it down here. And this time I'm now going to add some extra features into it. So one of the other parameters we can do is to specify the color of the plot. And we use the keyword color. So we say color equals, and I'm going to use the color green. We can also specify the width of the line by using a command or a parameter called line width. And the line width takes a floating point value. So I'm going to give it a value of 3 instead of the default value, which is 1. And lastly, we can also have line styles. And I'm going to create a line style which is called dashed. The various line styles that are available, let me just put them in here. Line styles, we can have solid, which is the default. The above, the first example used the solid line style. We can have dotted, we can have dashed, and we can have a dash dot style. There are also symbols we can use for these, but I prefer typing them out in full because it's easier to actually read and understand. So that will produce exactly the same data plot. As you can see, it's the same shape as the first plot we had, but this time we can see that the plot is in green. We specified the color green, we specified a line width of 3, so the line is a bit thicker, and the line style is a dashed line. Now we haven't finished with this because now I'm going to show you how we can annotate the graph. Now annotation simply means adding text to the graph. And the first thing we can do is to put a title on the graph. To place a title on your graph, we type plt.title, and then inside parentheses, we specify a string. So I'm going to just type my first plot as the string, and that will be displayed at the top of the graph. We can also specify labels for the X and Y axes by typing plt.xLabel, and again it is a string inside parentheses, plt.ylabel, and I'm going to specify Y axis. And when I run that, we can see now that those labels have been placed on the plot. The final thing we can add to the graph as well is a grid. Now grid lines are quite important on a graph if you want to try and read data points from that graph. And putting a grid on the graph is very simple. We type plt.grid, and that will turn on the grid. You can see now we end up with grid lines, so we can visualize the data points a lot more easily. The next example is to add 2 plots to the same axes. To do this, I'm going to create an x-axis, which I'm going to call 1, 2, 3, 4, and 5. So it's going to be exactly the same as the first example we did. But this time I'm going to create some extra data. So I'm going to have y1, which will be our standard data. We use 2, 4, 1, 3, 2. And I'm going to create another y list called y2. And this time, let's put some more different data in it. We'll have a 1, 3, 2. Let's go for 4 and 1. To plot them, we just type plt.plot x, y, 1, and I'm going to give it a label. So I'm going to say label equals, and I'm just going to say line 1 so that we can see. And then to plot the second one, we say plt.plot. We give it the same x-axis. This time the data contained for the second plot is in y2, and we can give it a label, and this time the label I'm going to specify as being line 2. Give it a title, plt.title, a second plot, plt.x label will be x-axis data, and plt.y label will be the y-axis data. And I can turn on the grid by typing plt.grid. So when I run that, we now end up with a plot showing us both lines on the same axes. You'll notice that Python will automatically separate those two lines out with different colors. Now, what I want to do is to show you a few extra things. Firstly, if we want to change the size of the plot, we need to use a specific command before we use the plot function. So in your program, before we use plot, I'm going to say plt.figure, and then inside parentheses we specify the figure size. So we say fig size equals, and then we need to specify a tuple, and this tuple will contain two integer values, which are the x and the y extent. So I'm going to make this graph a little bit bigger by specifying a size of 10 along the x-axis and 6 high on the y-axis. Right, so that command will simply, let me just write it here, change the size of the figure window. So when I run that now, you'll see that the figure window is a lot bigger. The second feature I would like to point out deals with these two parameters. For both these graphs, I've specified a label, and these can be placed on the graph by using something called a legend. So if we type plt.legend, what matplotlib does is it takes these two labels and displays it on the figure window. So if I run my code now, we'll see there is our major plot, and both these graphs are now identified by the labels that we have given it. So the blue line contains line 1, and the orange line contains line 2 data. The next step of today is going to be looking at scatter plots. So basically for this graph, we've got data points, and these data points are connected by straight lines. A scatter plot doesn't do that. A scatter plot simply allows the plotting of the data points only without joining those data points up. To be able to plot a scatter plot, we use exactly the same module, which is matplotlib.pyplot. As usual, I'm going to start by importing matplotlib.pyplot as PLT, and that is the basis of all our programs which allow us to visualize data. The next step is to generate some data. I'm going to create an x-axis with 10 data points in it this time, and I will create a y-axis. Let's get some data in there. 8, 9, 11, 12, 12. Right, so now we can get onto the plot command. The first thing I'm going to do is to make sure that the plot is a little bit bigger than normal. So I'm going to change it to my standard 10:6, and then I'm going to plot those data points out. To plot them out, instead of typing plt.line, we type plt.scatter, and the scatter function produces a scatter plot. Inside parentheses, again, we need to now specify various parameters, starting with the data that we want to plot in the scatter plot. So that will be our X data and our Y data. As usual, I'm going to give the plot a label. I'm just going to say my data. You can call it whatever you like. And then we can specify various parameters. I'm going to make these points in green. I'm going to then change a specific marker, and I will explain this just now. And I'm going to give it a size of 40. So each point or each marker will have a size of 40. We can then specify the standard, which is plt.title. This will call it a scatter plot. plt.xlabel and plt.ylabel, which will contain the X and the Y labels that we want to display. Finally, just like normal, we can add the legend if we want. Not strictly speaking, this is not necessary because we've only got one Y list, but we can turn on the legend and we can turn on the grid. There is a standard scatter plot, and if I run that, we end up with a scatter plot which looks something like that. So there is the data that is contained in my Y list, my list called Y, and is being plotted against list X, which is the X-axis. Now let's look at some of the properties or parameters that we had. Firstly, the color of green. We can change this color if we want. So for example, I can change it to red, and now we have those markers shown in red. If we want to change the actual marker itself, we can change the symbol. At the moment, I'm using a lowercase o from the alphabet, but if I change it to a decimal point, for example, we can see now that the markers are very small dots. I can change it to various other symbols as well. If I put a symbol called a caret in there, it now changes them to a triangle symbol. And again, this is quite handy if you are plotting multiple scatter plots on the same axes. It will allow you to identify the various plots. The size is the size of the marker itself. So at the moment, I mean, you can make these markers really big if you wanted to. So again, it depends on what you want displayed. I'm going to stick to a standard size of around 40 so that we can visualize the data a little bit easier. Just because we've got a scatter plot doesn't mean we can't use a line plot. So for example, if I did this and I type plt.plot X and Y, and now you can see we've got the scatter plot, which is the data in red, and we've got the line plot for exactly the same data. So all it's doing is joining up these specific data points that we've got. So all I've done here is I've combined two plots, a scatter plot and a normal line plot combined together on the same axes. Now, the problem with line plots like this and like we saw above is that your line plot simply joins the data together. There is no smoothing of the data. There's no manipulation showing you what the trend might look like. It is, strictly speaking, one point joined directly to another point. So what I want to do now is to introduce you to this other module called SciPy, used for smoothing out any discrete data that we might have. Discrete data is data points, actual data points that we've got. I'm going to be using this to plot a smooth line. So basically inside the SciPy module, we are going to use a function called spline, which smooths out your data. Spline curve is a mathematical representation which allows us to control the shape of complex curves or surfaces. So SciPy is the one module we are going to use, and we will also use the Numpy module to allow us to work with floats. This is important because at the moment all the data we've worked with doesn't contain floating point data. It is all discrete integers, and I need to convert this to floating points so that we get a whole lot of data points in between each of the data points that we've got here. The numpy.arrange function allows us to specify a minimum value, a maximum value, and a step size, and this will then generate an array of floats. First thing I'm going to do is to say import numpy as np. We also need to import matplotlib.pyplot as plt. And lastly, I need to import a specific function from SciPy. I'm not going to import the whole of SciPy, so I'm just going to say from SciPy import a function called interpolate. Just to make sure we've got the same data, I'm going to go back to our previous program and I'm going to copy just those lines of code so that I can put them into here, just so that I'm working with the same lists. So there we have our X and Y data, and of course we've got our plt.plot, and if I then run that, we end up with the data that we had previously. Let's just put some labels on it. That and there. I'm going to take out the title for now. There we have the data plot. Now what I'm going to do is to come into here, and this is where I'm going to interpolate data points between the given points that we've got. So basically what this means is that we have got data contained inside our list called Y, and the first point in there is 2, then it jumps to 3, then it jumps to 5. I want to generate a whole lot of points in between those specific data points so that we can then plot a smooth curve between each individual data point. To do that, I'm going to create a list, which instead of just being called X, I'm going to call it X new. So this is the new X data. And this is going to be data which is generated using the numpy.arrange function. Now what we want to do is to generate values from 1 to 10, but not just 10 values. I want to display or generate a whole lot of values. So np.arrange, the low value, the minimum is 1, the maximum is 10, and I'm going to tell it to use a step size of 0.1. Once we've got that new data, we are then going to create another list. I'm going to call it A, and I'm going to use the interpolate function that we imported from SciPy. I'm going to say a spline equals interpolate dot make interp spline, this function that I said here, interpolate.make_interp spline, and then I'm going to give it the original data we had, which was x and y. And then finally, the new y data, which we need, is going to be a spline and x new. All right, so there is the 3 lines of code we need, which generates our spline data. And once we've got the spline data, we can simply plot that out just like we did up here. So plt.plot xy, I can now type plt.plot x new against y new. All right, so that code that we have there generates our floating point data and allows us to plot it out. So this is now going to plot a whole lot of points in between each of these discrete data points that we have on the graph. And if I run that code, you can see now that we end up with 3 plots all on the same axes. We've got our individual points shown in red. We've got those points joined up shown in blue, and we've got our smooth curve joining up those data points, which is the spline data, which is done using that code there. If I take out this line of code here and I run it again, we can see now we've just got the spline curve joining up that data. The next step is to show you how to plot data from mathematical functions. So I'm going to start off by matplotlib.pyplot as plt, and very important, we need numpy, so I will import that as np. Again, both these functions have been renamed. I've renamed this one as plt and I've renamed numpy as np. It just saves me typing the whole time. So because we're dealing with sine data, we need the value of pi. So I'm going to create a constant for pi. And the value of pi is, luckily for us, it's sitting in the numpy library as np.pi. Now that we have pi, I'm going to generate 2 mathematical functions. I'm going to create x, a list, which is np.arrange. And let's go from -8 pi as a minimum value up to 8 times pi as the maximum value with a step size of 1. And now that we've done that, we can create our y data. I'm going to call it y1. And this time I'm going to use the mathematical function called sine. Now, because we are using floating point data, I'm going to use sine from the numpy library. So np.sine, and I'm going to create a function. I'm just going to basically, the function I want is going to be sine x over x. So that's what I am going to plot. So we've got sine x divided by x, where x is the data generated in that line of code. So x is going to be all data going from -8 pi to +8 pi with a step size of 1. y1 then generates data for our y list, the y-axis. We've got that, we can then plot it out. I'm going to make it a little bit bigger. Fig size equals 10.6. Use the standard values. I'm going to say plt.plot x and y1, and the label, let's call it sine x over x, just so that we know what the plot is. We can then put together our standard annotation, plt.title. I'm just going to put here functions because that's what we're plotting. We're going to be plotting some functions. Plt dot label, it's trigonometric, so it will be time, and plt dot y label is amplitude. Finally, we can type plt dot legend and plt dot grid. So if I run that, we end up with our response showing us the function which is sine x over x, and there it is there. Now you'll notice that the response shown here is not very smooth at all. In fact, it's very, very jerky. And the reason for that, quite simply, is because when we generated our x data, we simply do not have enough data generated in our list to smooth out that curve, because the step size we used is the default step size of 1. If I reduce that step size and give it a few extra data points, so I give it 100 times more data, I'm now generating a lot more data along the x-axis, which produces a lot more data contained in the y list. And if I run that now, you'll see that the response is nice and smooth. If you want to superimpose graphs, we can do that as well. So I can say y2, I can generate some more data. Let's go for a cosine graph, np.cos, and this time I'll plot half x, and again over 2. All right, so I've got x over 2 divided by 2, and then we need to add in another plt.plot. This time we're plotting x versus y2, and the label for this graph is going to be cos x over 2 divided by 2, so half. So if I run that code now, we can see now we've got two plots superimposed on each other. The legend has been specified based on the labels that we used for each of the plots. So there are the two plots, so we can identify it quite easily. Two other commands I just want to mention. You'll notice that when a plot is drawn in Matplotlib, there is some space on the left-hand side and the right-hand side. So, for example, the plot doesn't start from -8 pi and it doesn't end at 8 pi. It starts at integer values. Now, we can specify the x and the y limits of the graph that we want displayed. And to do that, we use the commands plt.xlim. The xlim command will specify the x limits. So here I'm going to say -8 times pi up to 8 times pi. So there is our x limit. And if I run that, we'll see now that the minimum value on x is -8 pi and the maximum value is +8 pi. Of course, if we don't know what those values actually are, we can extract them from our list called x simply by typing the minimum value in x and the maximum value in x. Thank you for watching this short introduction to data plotting. If you found this useful, please give a thumbs up and subscribe to the channel.